All right, guys, last little part here. It should go pretty quick. I just want to tell you why the Maclaurin series actually or why it actually works. Like, where is all this coming from? Okay. Well, the Maclaurin series is a power series. Okay, so here's a power series. So does it make sense? You can see the x to the fifth. That's this guy, right? X to the fourth, right? When you plug in, I'm kind of going backwards, but x to the third. So that part makes sense. But where is this part coming from? Okay, this is the c's. That is your c's. The constants, the coefficients, however you want to think of it. Those are the c's at the beginning. Okay. All right, so what do? We take the function and we evaluate it when x is 0. Well, when x is 0, all these go away, right? If x is 0, this whole term drops out. All these terms drop out. Each term drops out. And so this is then when x is 0, it gives us the very first number. Okay? All right? What happens then? We take the derivative. When we take the derivative, the constant, this guy, totally goes away. This is a number and we're adding. So if it's a number and we're adding, it goes away. This, think of this like a 7x, right? The derivative of 7x is just 7. So this term, the x goes away and we just have c. Here, we're going to roll this 2 down. So that's why I have a 2 here. And then it's subtract 1, x to the first. Roll this 3 down and then subtract 1. Roll the 4 down, subtract 1. So we get the idea. Then what happens when we evaluate the derivative at 0? All of these guys go away because they all have an x. So you plug in an x, you get 0. Plug in an x, get 0. Plug in a 0, did I say it again? Plug in 0 and it goes away, right? Plug in 0 for x, that's what I wanted. Plug in 0 for x and it goes away. Plug in 0 for x and it goes away. So when I evaluate the derivative, when x is 0, I get c to the first. Okay? Then I take the derivative of this. What happens when I take the derivative of this? This goes away. This coefficient, right, the x goes away, and so now I just have my coefficient. Roll it down, so now I have 3 times 2, x to the first, because I subtract 1. Roll this down, I have 4 times 3, subtract 1, x squared. All right, and you get the idea? Okay, so now what happens when I evaluate the second derivative with the 0? These all go away because I'm plugging in a 0. So the only thing I have left, now this one's a little bit different. I have 2c left. So to get c, I had to divide both sides by 2. Okay, and so that gives us this. Okay, all right, then let's do the next thing though. I take the derivative. When I take the derivative, the constant goes away, and so now I just have this, right? This is, here it is, 3 times 2, c to the third. My x is gone because I took the derivative. Roll it down, so now I have 4, 3, 2, x to the first. Roll this down, 5, 4, 3, but now I'm down to x squared. Then I let x equal 0. All of these guys drop out, okay? And I just have 3 times 2 times c to the third. You could even put a dot there if you wanted. Okay. How do I solve this, though? I have to divide by 3 times 2. Okay. And so that gives me that guy, which now gives me c to the third. Let's do one more, and then we'll finish it up. So here, actually, let's do it like this. So that we can see, right? Because we need at least the third. So this constant goes away. This now, I just have the coefficient, because at x to the first, when I take the derivative, then I just have the coefficient. Okay, and then this guy rolls down. Now, obviously, there's more, but this guy would roll down. So now I've got 5 times 4 times 3 times 2, and then subtract 1. So this becomes an x to the first. Okay, so now, though, I let x equals 0, so all of these terms, and there's others, but they all have x's in them. So all of them are gone. When I evaluate x to the 0, then I only have this guy. Okay. So that gives me 4 times 3 times 2, okay, and that gives me this. So then I divide by 4 times 3 times 2, okay, and that gives me then c to the 4th. But what is 4 times 3 times 2 times 1? 4 factorial. What is 3 times 2 times technically 1? 3 factorial. Okay. What is, where am I at here? 2 could be 2 factorial. Okay. This technically is just 1, right? But that could then be 1 factorial. Okay. And then this here, same thing, I can do 0 factorial because 0 factorial is really 1. Okay. And that's where, guys, that's where when I take the derivative and evaluate 0 and divide by my factorial, that gives me, that's right here, that gives me c sub 4. Okay, so that's why it's this guy, because when you take, when you keep taking the derivatives, you get the next one, but you get all the exponents that have rolled down prior as it kind of like shifts, and they're all like 5 times 4 times 3 times 2 times 1. That's why it's, oh gosh, you can't even see, shoot. That's why it's factorial. Okay, so where is this coming from? This, maybe the best way is to compare, let's make sure you can see it, is this here compares to that there. Okay, which I'm really finding, and what am I finding? I'm finding the coefficient, and if this was 4, I'm finding the coefficient of x to the 4th. And c sub 4 is the coefficient of x to the 4th. Okay, you can see the parallel there. As you take the derivative, you get more and more of these numbers. You get 5 times 4 times 3 times 2 times 1, so those are all stacking up there. But it's also kind of neat as you take the derivative and then you evaluate it at 0, all the other terms drop out. It's crazy, isn't it? The same thing with Taylor series. It's just a Taylor series looks like this. So you don't evaluate it at 0, you have to evaluate it at A so that all these other ones drop out. Okay, all right. So I just wanted to show you why that actually works. It's kind of neat, and it's not that hard. Hopefully it makes some sense. I got to leave you with this. I don't know if I hope you can read it. I'm going to do this. This is like the best comic ever. I'm probably plagiarizing, but math people, it doesn't matter. It says, this guy writes an equation for over 20 minutes, and he has the nerve to say, voila. It just reminds us of our class, all the times we wrote stuff forever. I don't know. It made me laugh. My husband didn't find it funny, but I loved it. All right. Take care, guys.